Fires and earthquakes strike suddenly without warning. As a way to assess the situation quickly and save lives, measurement and detection systems using terahertz waves are currently very topical. The importance of terahertz wave systems is now recognized worldwide, so development is underway urgently. This group brings together experts from the University of Tokyo, NTT, NEC, NICT, and their collaborating companies. Progress has been made through powerful teamwork by Japan's industrial, government, and academic sectors.
テラヘルツっていうのは、扱うのが基本的に難しいということがあって、そのためにですね、かつてはなんですかね、限られた専門家が基礎研究をやるというそういう分野だったんですね。だけど要素技術がかなり発達してきたということのために、この10年間ぐらいはその専門を超えて違ったいろんな方面に、応用して役に立つんじゃないかという意識が非常に広がって、でいろんな応用研究の応用の可能性が追求されてきたということがあって、日本はすごくいい基礎研究の蓄積があるんで、それをそういう産業化なりに結びつけていかなきゃいけないというそういう背景があるんだと思います。
Terahertz waves are a form of electromagnetic radiation, intermediate between visible or infrared light and the waves of radio or mobile phone signals. In areas where smoke or haze has arisen, the air is full of soot particles, so light, which has a short wavelength, is scattered by collisions with soot. But terahertz waves, which have a longer wavelength, can pass right through smoke, such that radio waves do so. Also, because they have a shorter wavelength than radio waves, their propagation direction is well determined, like visible light. By utilizing these two properties, terahertz waves can be focused on a desired target and detect objects without being disturbed by smoke or haze. To utilize the safety features of terahertz waves in safety technologies that haven't been possible with light and radio alone, each research group has collaborated on a test. The confirmation test was done in February 2011 in the Fire Science Center at Tokyo University of Science. The test simulated conditions in and outside buildings damaged by a severe earthquake and utilized two technologies, terahertz band remote imaging and terahertz band high-speed spectroscopic sensing. Terahertz band remote imaging captures terahertz band images from visually obscured emergency situations and uses information unique to the terahertz band obtained from materials databases to process the images. The aim of this technology is to achieve remote images that can be used to rescue people and prevent secondary fires. A terahertz camera is placed in front of the equipment in the affected building, and terahertz waves are sent to reflecting plates in the building. The reflected waves are captured using a terahertz camera, along with cameras for the visible and infrared bands, and the three types of pictures are monitored. There are pictures of inside the affected area from the visible, infrared, and terahertz cameras. As the temperature in the building rises and smoke is pervaded, the visible and infrared cameras become unable to distinguish objects on site. But as you can see, the terahertz camera can detect them until the fire has run its course. The other technology, terahertz band high-speed spectroscopic sensing, detects and identifies toxic gases generated in fires, including carbon monoxide and hydrogen cyanide. By detecting such gases from a safe distance through spectroscopic methods using terahertz waves, the aim is to help with rescue efforts. A transmitter installed behind the equipment in the affected building sends terahertz waves to a reflecting plate in the building. and a receiver analyzes the reflected waves to detect whether toxic gases are present. The results of these two tests are expected to be extremely helpful for safe, speedy rescue during actual emergencies. The tests bring together the results of numerous research programs that have been pursued separately so far. In the remote imaging research, NEC, NICT, and the University of Tokyo have collaborated on terahertz camera research and development. In the spectroscopic sensing research, NTT has collaborated with AIST and NGK insulators to develop sensors that detect and analyze hazardous gases. In addition, Tokyo University has developed a variable environment system for terahertz measurement simulations. Nagoya University and Spectra Design have collaborated in the research by gathering basic data on how terahertz waves pass through air and reflect from various materials. Now that a safe, secure society must be maintained in an age of ubiquitous networks, research and development on the practical application of terahertz waves is essential.
これから本当にテラヘルツがいろんな現場で役に立って産業化と合体していくということのためにはいろんな発生、テラヘルツの発生、それから検出、それから信号を扱う技術の要素技術がそれぞれ何歩かねやっぱり進歩していく必要があると思うんですけども、原理的なね問題はかなりクリアできるんじゃないかと。あとはですね、どのくらい本当にそうできるかっていうのは社会とか産業の方からニーズとしてどのくらいそれが欲しいんだっていうのが出てくるか、それから産業界なんか本当にどのくらい本気でやる気になるか、そういうことに非常によるんじゃないかと思いますね。
Terahertz waves are expected to enable new measurement technology for all kinds of analysis and security applications, as well as ultra-fast wireless communication at 10 gigabits per second. It is fair to say that the development of terahertz technology is a fundamental aspect of infrastructure for a safe, secure society.